Trigonometry numerical type. If sine square 10 into sine 20 degrees into sine 40 degrees into sine 50 into sine 70 is equal to alpha minus 1 by 16 times sine 10. The question is find the value of 16 plus alpha power minus 1. So we have on the given expression we have is nothing but sine square 10. When you see this sine 20 and sine 40, you can write 20 as 30 minus 10 and 40 as 30 plus 10. So we get sine square 10 into sine of 30 minus 10 into sine of 30 plus 10. Similarly, you can express sine 50 and sine 70 as sine of 60 minus 10 into sine of 60 plus 10. Now let me recall an identity for you. We know that very important identity in my view, sine of a plus b into sine of a minus b is equal to sine square a minus sine square b. This identity is very handy in many places. So let's apply this identity to the first two terms and also apply the identity to these two terms. So we get sine square 10 into, this is going to be sine square 30 minus sine square 10. What about the second bracket? We are going to have a sine square 60 minus sine square 10. Let us replace the respective values of sine square 30 and sine square 60. So I get a 1 by 4 minus sine square 10, and sine square 60 is a 3 by 4 minus sine square 10. Let us take this 4 as LCM and pull it out. We will get sine square 10 divided by 16. Inside the first bracket I get 1 minus 4 times sine square 10 into 3 minus 4 times sine square 10. Now what we are going to do is, we have a sine square 10 in the beginning. Let us push one sine 10 inside the first bracket and one sine 10 inside the second bracket. So the first bracket will become 1 into sine 10 minus 4 sine square 10 into sine 10. It will become 4 sine cube 10. One more sine 10 will go to the second bracket. This will become 3 sine 10 minus 4 sine cube 10. Let us recall the identity. We know that sine 3 theta is equal to 3 sine theta minus 4 sine cube theta. So if you see the expression inside the second bracket, I think we had a 1 by 16 outside. We had sine 10 minus 4 sine cube 10 in the first bracket. Sine 10 minus 4 sine cube 10. Inside the second bracket what we have is 3 sine theta minus 4 sine cube theta, where theta is 10. So 3 sine theta minus 4 sine cube theta is sine 3 theta. So it becomes sine 30. You can replace the value of sine 30 as half. So that gives us 1 by 32 into sine 10 minus 4 sine cube 10. But if you see the right hand side of the expression that you are concerned, there is a constant and there is a 1 by alpha sine 10. That means we are not interested in a sine cube theta, sine cube 10. We are interested only in a constant and a sine 10. So use this identity number 1 once again. From here, write 4 sine cube theta as 3 sine theta minus sine 3 theta. 4 sine, so sine 10 remains as it is. 4 sine cube theta becomes 3 sine theta minus sine 3 theta. Sine 3 theta will be sine 30. Now open this bracket. You will get sine 10 minus 3 sine 10, which is minus 2 sine 10. Minus into minus plus, so you get a plus half. I think you can take this 1 by 32 inside the bracket. You get a 1 by 64 minus 1 by 16 times sine 10. So we have managed to express the given expression as some constant and some sine 10 term. Let us see what it is. Alpha minus 1 by 16 sine 10. So it is alpha minus 1 by 16 sine 10. You can see that this term matches with this term. So we know alpha should be taking a value 1 by 64. What we exactly need to find out is the value of 16 plus alpha power minus 1. 16 plus alpha power minus 1 is equal to 16 plus 64, which is equal to 80. It's a simple numerical type using only two identities. One identity which we need to know is sine of a plus b into sine of a minus b, sine square a minus sine square b. The other identity is 3 sine theta minus 4 sine cube theta is equal to sine 3 theta. So the answer to this question is a simple integer, namely 80.